So what I am saying is, as we're going down the stack, right? Whatever is in the application, that will be like the smallest doll. Then it's going to be inside the next doll, which will be the presentation. And then that one is going to be inside another one, which will be the session. And then that one inside the transport one, right? Now, as I mentioned, these three layers sometimes get a little bit like intertwined. So let's just think that this payload that it's within all of these, right, is going to get into the transport layer. And the transport layer is going to send it from end to end, either in a connection-oriented way with TCP or connectionless using UDP. Every time a new doll, it's placed above, right, and it's grabbing the smaller one, we call that encapsulation. And that little header, that capsule, in this case we're thinking, the doll, right, it has its particular header and everything, all the information needed for the next layer down. Okay, when we're encapsulating, when we're decapsulating, it's being taken off, it's being opened and it's being sent up. Okay, now when we're talking about the transport layer, right, the header, those parts that actually have very, very specific information related to this particular layer, in the case of the transport layer, they have something called a port number. Okay, we'll talk about ports later, but so you know, transport layer, right, it has a port number. And the way that the transport layer payload is called a segment. And it is called a segment because maybe sometimes, the message that is being sent from the layers above is way too large, right? And when it is too large, TCP divides it into smaller segments, right? Into smaller pieces. And then it sends them in an organized way so that they arrived properly. Why is this done this way? Well, because TCP is connection oriented, right? So it's going to establish the connection from end to end. Then after it establishes the connection, it starts sending, the messages one by one in order, and it actually has a mechanism to ensure that these messages are in order, either at the sending part or at the receiving part. But TCP in the receiving and the sending computer work together, using ports and using segment numbers to make sure that all the information is delivered, and that it is delivered in order, because TCP is connection oriented and is a reliable protocol. On the other hand, we have UDP, which is the rebel, right? Because UDP is unreliable, right? And it doesn't need a connection. So it doesn't even tell you when it's going to go or where it's going. It's just a rebel without a cause. So it may go, it may not go, and it may not even get there, right? But even when it's unreliable, right, UDP is used in several applications which actually need that kind of unreliability. And it's not because, I want something to be unreliable, I want to be wondering if it arrived there or it didn't. No, it's not because of that. It's because, either you want something that it's actually a little slower, but it's reliable, or you want something that is super fast, but it's unreliable. And notice when I tell you that it's unreliable online, doesn't mean that it never arrives or that it's a 50-50 chance that it doesn't get there. It means that it probably has a 98% chance of arriving well and a 2% chance, or maybe less than that, of not making it, right? Whereas TCP is almost 100%. So it's just a little bit of a percentage, right? So the unreliability, quote unquote, is not that terrible. So finally, we see our transport layer protocol right in here, right? And remember, this is the protocol that actually ensures that the communication goes end to end across the network, and it has two modes. Remember, it can be connection oriented or it can be connectionless. Connection oriented is a little slower, but it's in order and it's guaranteed delivery. However, connectionless, right, is super fast, but you have a greater risk of it not arriving to the destination. So we will continue moving down, right? So we're at the transport layer. We're going to get into the network layer.